Welcome to our Physics 2 lab on charged tapes. So the purpose of the lab is to determine the interactions between clear tape and other objects by charging the tape and determining the excess charge of the tape. We can model these interactions with GlowScript by noting that the tape is the system and the surroundings such as hands and any books or chairs that are holding tape B together are our surroundings. So tape B, as you can see here, when it is a neutral tape and another tape which is charged are interacting, the charged tape should cause the non-charged tape to sort of float, and when it is in that equilibrium, we would like to use that information to determine the charge on the tape, as well as the deficient electrons, which we have a little equation here to find the deficient electrons. We'll do all this by noting that when we are in that equilibrium state, the electric force added to the gravitational force is equal to 0, so that means the gravitational force is equal to the negative of the electric force. And here are our force equations, as well as an equation to find our charge, which we will use later in the coding section of our lab. So we also have some key values. The length of the tape A, is 0.21 meters or 21 centimeters, and the mass of the tape is approximately 2.299 times 10 to the negative fifth kilograms, which is extremely small, which is also why the forces are extremely small. And the distance while floating is 0.25 meters, and as you can see, because this is a magnitude, these two are going to be equal because the gravitational force is equal to the negative electric force, and it will be the vectors that are actually including that negative value. So we're all going to ask ourselves, what assumptions and approximations are we going to take into our lab? And we are going to assume that the tape can be treated as a point charge with all the charge concentrated at the center, and that the charge is going to be similar with both tapes. And so the magnitude of the charge on one piece of tape does end up being calculated as this number right here, and the number of deficient electrons, the number of atoms, and the ratio of deficient electrons to atoms is written down here, which this is our outcome of the lab that we will go over a little bit later. So this is our code. We start by taking in all of the values that we will need to calculate these equations right here. Because of the fact that we know that this equation holds true, we can find the gravity equation, since we don't know our charges, to find the electric equation actually, or electric force specifically, which means that we can calculate for our charge. So once we have calculated for our charge, we can also calculate for the number of deficient electrons by dividing the surface area of the tape by the charge of the electrons, and then we can find the number of atoms by dividing the surface area by the number of atoms per unit of area, and then we can find that ratio by just putting 1 over the number of deficient electrons over the number of atoms. And then all of this is just so that we can actually see these values, which again, just as we found in our introduction, are equal. The charge is extremely small, but the number of deficient atoms and the number of deficient electrons and the number of atoms are extremely large numbers, and it comes out that there is about 1 electron per 16 atoms, which means that it's about every 16 atoms there's an electron that is causing that charge. And as for observations, when two U-tapes are placed near one another, they both repel. If a U-tape is positively charged, obviously it attracts negatively charged things and neutrally charged things by creating an induced dipole, but it does repel other positively charged objects. These similarities and differences or causes for errors in our model are caused by these assumptions that we made. So if we were to model it differently, we would get different values.